Okay, so polynomial unit. We start off by looking at like how to add and subtract polynomials. So I'm just making the assumption that everybody's good with adding and subtracting polynomials. Yeah? Yeah. So if you're adding or subtracting polynomials, right, we're just essentially combining like terms, and like terms have to have the same degree. Then we're looking at multiplying polynomials. So I'm just going to go through a few questions. There is a variety of strategies that you can use to multiply polynomials. Whatever works for you is what I suggest that you stick with. So really the two main ones that I look at are either using grid or using distributive property. So looking at example number A, 4x cubed y times x squared minus 2y squared. If they're asking me to multiply this out or asking me to simplify, what you're having to do here is take whatever is in front and multiply it to each term on the inside. So I'm taking 4x cubed y and timesing it by x squared. So really, this is a combination of multiplying polynomials and exponent laws. So if I'm just going to rewrite, just for the sake of what's happening, 4x cubed y times x squared, and then 4x cubed y is being multiplied by negative 2y squared. That's what's happening, right? And I would never really write that out. I would just look at it and start multiplying. But so when I'm looking at multiplying here, well, there's no coefficients to multiply, so I would just keep that as a 4. X cubed times x squared is going to give me x to the power of 5. And then y is not being multiplied, so it's just y. Then the next one, I'm multiplying 4x cubed y times negative 2. So that's what's happening right here. So I'll multiply my coefficients together. So 4 times negative 2 is negative 6. X cubed, there's no x to multiply 2, so that's going to remain x cubed. And then y is being multiplied by y squared, so that's going to be y to the power of 3. So there's my answer if I multiplied that out. There is a few different ways if I really wanted to know how to verify. There's two different things I could do here. I can either factor it out. So if I have something that's multiplied, if I undo that, I factor it so I could see if that gave me the same answer. Or I could choose an arbitrary value. Make x equal 2, y equal 3, and see if this equals that. That can work. If I only have a single variable, I can always graph it to see if they remain the same graph. And if you wanted me to explain that to you later, I can do that. Kind of a shortcut. All right, B. 4a minus b all to the power of 2. So kind of a big question or a big multiplication question that a lot of people will mess up on. How do I properly multiply that out? I just do this. Power of a power. Well, it wouldn't be in the multiplying polynomial section if it was just power of a power, but I can only do power of a power if I have a monomial inside the brackets. That's a binomial. And so how many 4a minus b's are there? 2 of them. So this is actually equivalent to 4a minus b times 4a minus b. And so now that I have those two binomials, I can choose what strategy I use to multiply them out. This is distracting. Thank you. So if I'm multiplying that out, I can do two different things. I can either do the distributive property, which is taking everything in the first bracket and multiplying it to everything in the second bracket, or I can use the grid. Which one should I do for this question? I'm going to do both. First one, so distributive property. So distributive property, multiplying everything in the first bracket to everything in the second bracket, also called FOIL, but I'm not a big fan of that. So 4a times 4a is going to give me 16a squared. 4a times 4a is 16a squared, right? A times a to the 1, add those together, get a squared. And then I'll take this and multiply it to the next term. So 4a times negative b, so 4 times negative 1 is going to be negative 4, and then ab. So it has to be everything in the first term to everything in the second. So now I'll do the same thing with b, right? I'm essentially just rainbowing each term in the first bracket to each term in the second bracket. So the first one that I did right here, negative b times 4a is also going to give me negative 4ab. And negative b times negative b is going to give me a positive b squared. That sucks. I don't know what it was, but it sounded like it sucks. Okay, so then what I can do, like this isn't going to be my final answer. I always need to combine my like terms. So 16a squared just remains as 16a squared. And then minus 4ab minus 4ab. So combine those by adding them together. So minus 4 and minus 4 is going to give me minus 8ab plus b squared. So there's my final answer if I multiplied out 4ab all to the power of negative 2. Or pardon me, 2. Once again, I could technically verify I'm right by trying to factor and like move back up. That's always a lot of work. Or I could substitute an arbitrary number in for a and b. Or I could multiply out again, just see if they got the same answer both times. C is now I'm taking a binomial and multiplying it by a trinomial. I can, again, either do distributive property or grid. So I'm just going to model how to multiply out using grid here. And so using a grid, what I would do is I take each of these and I put them on a side of my axes. So this would be 6f and a minus 5. So I break up my binomial or trinomial or polynomial up into its terms. So that's the 6f minus 5, and I'll do the f squared minus 3f plus 1. And now that I've set that up like that, I can just see that each term is going to multiply to every other term just inside of the grid that I have set up. So if these are being multiplied, when I come here to right here, this is 6f times 6f squared. So 6f to the power of what? F times f squared. F to the power of 3. And I can just keep filling this out, right? So then I follow. So 6f times negative 3f is going to give me negative 18. F times f is f squared. And then at the very bottom, top right here, my grid, 6f times 1 is just going to give me 6f. And I just want to fill this out. So negative 5 times f squared is negative 5f squared. Negative 5 times negative 3 is a negative 15f. And negative 5 times 1 is going to give me a negative 5. I find the big problem that people mess up with this. Yeah. Thank you. Yeah. And that's exactly where people mess up. Thank you. Is people are just going to mess up usually on like basic multiplication, like 2 times 4 is 6, something like that. Or they'll mess up on exactly what I just did, which is not putting the proper positive or negative in there, and then that'll lead you to combining like terms incorrectly. I'm not done here if I use grid. Same thing, I wasn't done over here when I did, distributive property. Last thing I need to do is combine my like terms. So 6f cubed. There's no other 6f cubed, so I'll just write that down. Now I have a negative 5f squared and a negative 18f squared. So to combine those, negative 18 minus 5 is going to give me a negative 23f squared. Let's do this. So 15f plus 6f is going to give me a positive 21f, and my coefficient, or sorry, my constant is 5. Not nearly as easy to we really don't have a strategy to factor that out. But you could substitute an arbitrary value in for f and see that they should equal each other, or you could actually graph this and graph that, and you should end up with the same function as the graph. I could have also done distributive property where I'd have to multiply 1, 2, 3, 4, 5, 6 times. Either way, multiply it, I'm going to do 6 times. Questions for multiplying? Usually the easier of the one. All right, factoring. Oh, wrong way. All right, factoring polynomials. Factoring polynomials is one of the most important skills for like success in 20-1, 20-2. And so I think there's probably at least 5 or 6 questions, if not more, on factoring on your test. So big thing that you have to know. I don't really have enough room to usually like set this up and review it the way that I would like. So I'm just going to kind of make do with what I can fit on the screen here. So first thing, if you remember the factoring polynomial unit, what's the first thing we had to do for every question to make our lives easiest? What did we always start with? If you have the notes, it's like a sideways page that I set up there. Very first thing at the top center, what do I say you have to do? First thing, you look at a factoring question, you should always try and take out the greatest common factor. So that's what we'll look at. So the first thing you're going to do is remove the GCF. Now, it's not like greatest common factor between 3 and 8 now. It's the greatest common factor between a polynomial with multiple coefficients and variables. So remove the greatest common factor. And so if you remember what we're doing here is we're moving the largest numerical and the largest number of variables that can be removed out evenly from each term. And then once you've removed that, but when I say remove, we're dividing that out. That becomes your coefficient in the front, multiplied by everything that's left. And so if I look at this example that I want to look at, so I have 4x cubed y5 minus 16x cubed y to the 6th. Now, sometimes the greatest common factor might just be like 2, and that's easy. A little bit more difficult questions where I have something like this. So first of all, let's just start by taking a look at this. And without doing any other work, let's just identify the greatest common factor. And to identify the greatest common factor, easiest thing to do is just break this up. So the greatest common factor between 4 and 16 is what? 4. And always a nice place to start is, does the smallest number go into the biggest number? Yeah? Well, then that's going to be the greatest common factor. If it was something like 4 and 15 is not going to work. 16 is there. 8 works. Oh, 20. Still doesn't work. Anyway, just see if you can find a number that divides evenly out of both of them. Then we're going to go to x's. So I have 3x, or I have x cubed, which means I have 3 x's, and I have x cubed. Well, how many x's can be removed evenly from both of those terms? 3. So we can take out x cubed, or factor out x cubed from each term. And then I have y to the power of 5 and y to the power of 6. So how many could I divide out or remove evenly from each of those terms? Can I take out 6? Why not? I can't take 6 away from this 5, yeah. So this would be, the GCF would be y to the power of 5. So what you're doing if you're writing this in factored form, remember factoring is like undoing the multiplication of polynomials. What things got multiplied together, what polynomials got multiplied together to result in this polynomial? So when you're just doing greatest common factor, essentially what you're doing is dividing or removing your GCF from each term. But when we're dividing that out, we're not going to get rid of it because we want it to be an equality. It should remain equal. So we take the 4x cubed y to the 5. We'll place that in the front. And then we want to write what's left after each term has been divided by the greatest common factor. So 4x cubed y5 divided by 4x cubed y5. What's that going to give me? 0? Right. 4 divided by 4 is 1. 5x cubed divided by x squared, or pardon me, cube, 1. y5 divided by y5 is 1. Well, I can't just, it's not just gone, right? We still have to have something to hold its place. So we put a 1 there. The next one would be this. So 16 divided by 4x cubed y5. So 16, pardon me, negative 16 divided by 4 is going to give me a negative 4. The x cubes would cancel each other out, and I'd be left with y. And so there is my final answer in factored form. Sort of remember that? Easiest type of factoring. Okay. Factoring is a little bit easier to verify than multiplying, because how could I check that this is the right answer? That's a better word, thank you. Yeah, right, I can verify this by just multiplying it out. If I multiply this back in, I should get back where I started if I did it right, right? And so if you're really, really stuck on the factoring portion of the test, at least for the multiple choice section, you just multiply out A, B, C, D. Which of them gets you back to what you're supposed to be factoring? That'll always work. Okay, that's always going to be the first thing you should do in every single factoring question before you start, and then like going by cases. always start there. The next thing that I do from there, once I've removed my greatest common factor, and this one I can't really do anything, but once I've removed my greatest common factor, I then want to see, do I have 2 terms or do I have 3 terms? Most of what we were looking at is in, so let's see, how do I want to do this? And again, if you look at those notes, they're kind of laid out sideways. So you can just follow the chart as to where you would go. But if we have 2 terms, that's an I. So if we have 2 terms, there's really only 2 things I can do if I have something that have 2 terms: GCF or difference of squares. So 2 terms is going to look something like this: ax squared minus c is usually what we call it kind of in general form. And to factor this, factor 2 terms, we're either using GCF or you're going to use difference of squares. And difference of squares is an easy method of factoring. It should be identifiable because difference of squares has 2 terms. There being what? Difference subtracted, and A and C are going to be perfect squares. So 2 terms being subtracted that are perfect squares. Usually that's what we're looking at. So if I look at my examples, 25x squared minus 81. I'll do that so here. 16x to the 4 minus 1. So let's say they gave me those 2 examples and they say, like factor them or which is equivalent. You need to take those and factor them. So first thing I want to do is looking at 25x squared minus 81. Does anybody remember how to factor difference of squares? No? Okay, I'll go back up here then. So factoring of difference of squares, because both terms are perfect squares, my easy shortcut to do this is to take the square root of each number. So right, if I square root this, I'm going to break this up into like ax minus c and ax plus c. Right, so I can technically square root each term and break them up into conjugates because they are perfect squares. I could say that I'm looking for like cases, but I'm not going to do that. So 25x squared minus 81. What I do is I break this up into 2 conjugate terms. So I'm looking for what binomials got multiplied together to give me this resulting difference of squared polynomial. So if I square root 25x squared, what do I get? 5x, right? Square root of 25 is 5. Square root of x squared is x. So 25 is 5x. Then I do the same thing with the square root of 81. What's the square root of 81? 9. 9. 9. And I broke those up into conjugate terms. One's positive, one's negative. And now I'm done. I'm going to add, this is a 16x, that's a harder example, so I want to see if you can try one on your own. Let's go with, okay, take a second and see if you can do that one. 100a squared minus 4b squared. If you were to factor that with difference of squares, what would you get? And sorry, just to go back here, I could always make sure that I did my difference of squares right by multiplying that out. Distributive property, FOIL, grid, whatever you want to do. So 100a squared minus 4b squared. Should be nice and quick. Anybody want to give me an answer? Tara got an answer? What'd you get? Perfect. Yep. So I'm going to square root each term. So the square root of 100a squared is 10a. And make sure whatever you like is written first, that's going to be what comes first in your binomials. And then I would also square root 4b. So the square root of 4b squared is 2b. And they become conjugates. So one of those would be positive and one of those would be negative. Sort of remember that now that we've looked at it. Everyone at first was really confused, but we're okay. Okay. All right. The last one is a little bit more difficult, and I just want to show you why. So 16 x to the 4 minus 1. So still two terms being subtracted, and they're both perfect squares. 16 and 1 are both perfect squares. So I can use this difference of squares. Well, I will square root and square root. So if I'm creating my brackets here, the square root of 16 is 4. What's the square root of x to the power of 4? X squared, yeah, because it has to be the same numbers that would add to give me 4, so that'd be 2 and 2. So x squared. And the square root of 1 is what? Square root of 1 is 1. So 1, 1, and conjugate, so 1 positive, 1 negative. And if you stopped and you said, that's my final answer, you pick that as A, and the question said simplify to, like, simplify in smallest factor form or whatever it says, and you pick this as A, it would be wrong. Does anybody know why? Because why? Right, this, I can't factor this guy any further. That's factored, 4x plus 1, done. This one right here, however, 4x squared minus 1 is not in fully factored form. That is another difference of squares, right? 4 is a perfect squared, 1's a perfect squared, they're being subtracted, and it's only two terms. So now I'd have to do this again. So I'd square root this to become, so the square root of 4x squared is going to give me 2x. And the square root of 1 is going to give me 1. So plus 1 minus 1. And I would just bring this guy down, 4x squared plus 1. Can I go further? Why can't I go further? Yeah, 2x squared is not a perfect square. There's no other perfect squares or difference of squares there. So that would be that in factored form. And in none of the other examples that we did before was the degree 2, or was there another perfect square that you could keep going. But just in the odd case where you have a 16, and or if you had 1s, you can keep going. So just kind of be careful that whatever you're left with as that term, as the binomial that has the subtraction in it, isn't another difference of squares. Good? Okay. So then we said, all right, so we start off by looking at polynomials, remove a GCF if we have one. Then we say 2 terms or 3 terms. If you have 2 terms, you can do difference of squares. If we have 3 terms, we're looking for, so if I have a 3-term polynomial, we have a polynomial in this term, ax squared plus bx plus c, where a, b, and c could be any integer. And then I can have 2 different ways that I look at this. If I say a is equal to 1, I would solve in a certain strategy. If a does not equal 1, I'll use a different strategy. So first of all, I'm just going to focus on if a equals 1. So I'll just, pardon me, put some examples here. Okay. So x squared minus 7x minus 21. So if a is equal to 1, now this is a quick factoring by case is kind of what I'm showing here. But what I show at the very end, you can use that strategy for any question. So if a is equal to 1, what we say is if a is equal to 1, we're looking for 2 numbers that multiply to c and add to b. Whatever those 2 numbers are going to become your integers in your binomial. Those numbers become the integers in the binomial. Right, so what I'm trying to do is I'm trying to make this become some binomial. X plus or minus some number and x plus or minus some number. What I want to go figure out is what are those numbers? And so if I'm using this where a is equal to 1, I'm looking for two numbers that multiply to c and add to b, and those are going to become the integers in my binomial. So let's use that strategy to help us factor x squared minus 7x plus 21. So here's a, here's b, and here's c. So in this question, I'm looking for two numbers that multiply to 21 and add to what? -7. Make sure, regardless if it's a or b or c, that you bring your sign with it. Is it positive? Is it negative? So I'm looking for two numbers that multiply to -21 and add to -7. Yeah, but I don't need to put my plus in there because right now it's just indicated as. Did I say -21 or? Yeah, sorry. That's right. Right, I'm taking exact numbers that are in there. Sorry. So two numbers that multiply to -21 and add to -7. What are those numbers? Did that not work? No. Why did I pick that? Yeah, I can't get there. Okay, what do I have to change that to? Oh, that's exactly it. Yeah, I have. Apparently I'm dyslexic. Thank you. 12. Thank you. All right, that'll work out. All right, so two numbers that multiply to 12 and add to -7. So I'm just going to go through and kind of like look at the factors and see which ones I can make multiply to 12 and add to -7. In order for numbers to multiply to a positive number and add to a negative number, I have to have I have to have two negative integers. So this would have to be -12 times negative, or -1 times -12. If I add those together, -1 plus -12, I'm going to get a -13. So, right, I'm not looking for this. Those are not the numbers that I'm looking for. I could do 2 and 6, right? So -2 times -6, that's going to give me 12. That gives me 12. But if I go -2 plus -6, I get -8. Again, that's not what I'm looking for. So the numbers that I'm looking for are -3 times -4, which is -7. So plus -4 is going to give me -7. So those are the numbers that I'm looking for. And so I can just break those up into my integers. They just directly become the numbers in my binomial. So this would become x minus 3 and x minus 4. And I'm done. And that only works if a is equal to 1. If a is a larger number, that's not going to work for you. Okay, so let's put up another one. Okay, so take a second and see if you can solve this, even if you're not writing it down. Maybe try it in your head. So I'm looking for x squared minus 2x minus 35, and I'm saying, take that and factor it. Or what terms got multiplied together to give me x squared minus 2x minus 35. So once again, I have to look for a, b, and c. A is equal to 1, so I can use this shortcut strategy where I'm looking for two numbers that multiply to what? Multiply to, thank you, -35, and they have to add to -2. Did anybody get those numbers really quickly? 5 and -7. So 5 times -7. If I add those together, that's going to give me -2, so that's good. So I just break those up right in my binomials. X plus 5 and x minus 7. And I can always check that I'm right by just multiplying that out. Multiply this out, and I should get back up there. I could also graph that. y1, y2 should get the exact same function. All right, last factoring form, and then I'm done. All right, last one's a little bit more complicated. So now, again, I'm still looking at trinomials, but in this case, a does not equal 1. The thing to know is, like, if you got stuck and you didn't remember any of the other ways, you can always solve all questions using this strategy. And I'm just going to kind of write the steps as I show an example. So I'll look at the first one I have there. So example is I have 2x squared plus 9x minus 5. So if I had this question and they say factor it, the first thing I'm looking for, sorry. Oh, sorry, I thought you had a question. 2x, if I'm looking at this question and they said factor it, the first thing I'm looking for is a greatest common factor. If there's a greatest common factor, it might make my life easier, right? Like if I can take this out, and if this doesn't work, but if everything was divisible by 2, then I'd have a equals 1 and my life would be easier. I can just do my shortcut. So I take out a greatest common factor. Is there a greatest common factor here? No. All right, so I have 3 terms, now I have to use this very particular strategy. So in this case, we are looking for, as soon as I know a does not equal 1, I'm looking for 2 numbers that multiply to a times c and add to b. So now if a does not equal 1, I need to include that in my factoring process. So 2 numbers that multiply to a times c and add to b. So this is a, b, and c. And just to save space, I'll just move up top there. So I'm looking for 2 numbers that multiply to a times c, so 2 times negative 5. I'm looking for numbers that multiply to negative 10 and add to b. So those numbers need to add to positive 9. Anybody? What are those 2 numbers? Multiply to negative 1 and 10. Thank you. Negative 1 times 10. Negative 1 times 10 is negative 10, and negative 1 plus 10 is 9. So that's good. So those are my 2 numbers. Anybody remember what to do next? Oh, good. Go for it. Right. Yeah. So I'm going to split that middle term. So I'm going to split the middle term into the 2 numbers that I just found, into 2 numbers from that step, right? With the variable. Okay. The big thing is, like, I can't just put a negative 1 and a negative 10 in there because I want to preserve equality. Negative 1x and 10x are equivalent to 9 if I add them together. So 2x squared, I don't change the a, I'm just splitting the middle term. So I split the middle term into negative 1x plus 10x minus 5. Anybody remember what to do now? Before that, we need to put brackets around my first 2 terms, last 2 terms. So brackets around first two terms, last 2 terms. So here I would put brackets around my first 2 terms, which is 2x squared minus 1x, and brackets around my last 2 terms. And now what? Not the GCF, right, from each bracket. So going back here, looking at this first set of brackets, 2x squared minus x, what's the greatest common factor? Between 2 and 1? 1. Between x squared and x? Between x squared and x? X. So the GCF from both of those terms is x. The greatest common factor in the second set of brackets, 10x and minus 5, would be 5. And so if we remember, what we do is we bring the GCF to the front, and we're actually going to like factor using GCF each set. So 2x squared divided by x is 2x. And negative 1x divided by x is just negative 1. Make sure that you include the 1. That'll be a big place where people mess up, is they'll just end there. You have to include the negative 1 as a placeholder. Yep. Mm-hmm. I generally only take out a greatest common factor as a negative number if it's the first term here. Don't take out a negative unless you have to if it's the first term. It's kind of just a better rule to follow. So then if I, looking at the second term here, 10x minus 5, if I take out the GCF of 5, 10x divided by 5 would be 2x, and negative 5 divided by 5 is going to give me negative 1. And we have this beautiful thing happen at this point. I know I'm on the right track. Why? Right. So remove GCF from each, and factor. What's left should be identical. So what's left, like in brackets, should be identical. If I would have taken out a minus 5, like you were saying, then I would have had like a negative 2x plus 1, and then those wouldn't have been identical. So yeah, if this was negative or if this was negative, then I will take out a negative term. But that's not what happened there, so I didn't need to. And so if that's identical, essentially what's happening is we're removing that now as my greatest common factor. So these become one set of factors, 2x minus 1. And what's left in front, x plus 5, becomes my other set of factors if I remove that as if it was the GCF. So remove identical binomial. So remove the identical binomial as a GCF. That's one factor. What's out front becomes the other. Front becomes the other. And again, those steps are probably a little bit more detailed in the review notes that I gave to you guys. So take a look at that as well. Should I do another example? Yep. I can put x plus 5, 2x minus 1. Like, yeah, the order doesn't matter. But if I said, like, x minus 1, 2x plus 5, then that'd be totally wrong. Yeah. But the binomials can switch order. That wouldn't matter. And I can always check that by multiplying that bad boy out, and then I'm done. Any other questions? Should I do another example, or you feel good? We're good? Everyone's like, I want to go home. I've been at school for 2 hours.